Contact. No. Torch only we'll put. That is not. Nice. 12 volt.
That exactly. Okay, guys, we just. One second. I am just adding a few more people to the stream just to ask them to be part of the live stream. So I am supposed to be sharing. Great. So what we will learn now is to build a drone. This is something that I built a while ago. And I'll go into details of how this is built, what we've been using, and we'll keep this discussion going. Great. So the primary thing about a drone is you will need motors. So I have a couple of motors with me, which basically are something like this. Where is the motor? Motor. This is a motor. So I have a motor called Avionic C2830. So this is what you'll see, C820, and it also says 850 kV. Now, when you say this is a specification of this motor, primarily this is a brushless motor. I'm just trying to remove this. So it's a brushless motor. A brushless motor usually comes with 3 terminals, 1, 2, and 3. Why it's called a brushless motor is it's similar to it's not similar to a DC motor, but this is a DC motor. The magnets is what rotates and not the coil. Now there is a stator and armature. There's a stator and an armature, and this is what rotates, which has a lot of magnets. And what's inside is a coil, which is connected to these 3 wires. Now each of these wires are given a pulse. What is this? Che, my yellow teeth are all visible. Okay, I hope this is clear. No, that is. Okay, so what we have here is this motor. Now, a very important thing that you have to note in this motor is the 3 wires that come and the thickness of these wires, which very specifically says how much current each of these wires can take. Now, there are bigger motors which come with thicker wires, which means it can take more current. And do not compare these wires to that of a normal wire, because these are all silicon wires, which means compared to its size, it can take much more current and it can sustain some amount of heat. Now, looking at the specification of the motor, let's look at what 850 kV means. Now, 850 kV refers to how much rotation this motor rotates for every 1 volt you give to the motor, which means if you give 1 volt to this motor to rotate, it will rotate 850 RPM at 850 RPM. Now, which means if you give 10 volts, this motor rotates at 8,500 RPM. And if you give about 11.1 volts, you just multiply and you'll get the RPM this motor rotates at. So all of these motors are brushless, primarily because there's very less friction. And because there is very less friction, you will be able to run this at very high speed, because you need that much speed to generate the thrust required to take off. Now, once you're clear with how much voltage you give to the motor, so every motor comes with a specification that says you are supposed to be giving a maximum of 11.6 volts or 11.1 volt or 14.6 volts, depending on the specification of the motor and the way the wires are wound inside. Now that is with respect to the kV. Also note, the higher the kV, which is like there are motors which come with 3000 kV, 4000 kV, the lesser the torque it will generate, the higher RPM it goes at. So the higher the RPM, the lesser the torque or thrust it can generate. So higher kV motors are used in small drones, which are usually used for racing. And the lesser kV motors are used for drones that carry heavy weights. Say, for example, if you're using a 150 kV motor, you can lift at least about 10 kilogram of weight if it's a quadcopter. And it can be a little more if you're using a hexacopter. Now, this is the motor. And what is this number 2830 meaning? The 2830 is typically telling the size of the motor, which is calculating the width of the motor and the height of the motor. Right? So it is about the dia of the motor and the height of the motor, and also the mounting holes. These are called the mounting holes in a motor. What you see here is a mounting hole, and those mounting holes is what you will need to be careful of, because when you mount the motors on a drone, a frame like this, so I have a frame, these mounting holes have to match. If they don't match, you will not be able to use these motors. Okay, that's with the motors. Now, another important thing to drive these motors is what we call as a ESC. ESC has, again, 3 wires which controls the motor, the speed of the motor in the direction. And you have 2 wires on the other side which goes to the battery. And there's 1 wire which is a 3-pin wire which basically takes the signal for your motor to rotate. This comes from a controller or a speed controller or a potentiometer, which basically gives a pulse to one of these pins, which is the yellow pin that you see here. It gives a pulse to the spin, and this controls the speed of the motor. Now, what you will have to also keep in mind is not all ESC or electronic speed controller come with 3 wires like this. Some only come with 1 wire, which means they have an inbuilt 5 volts in ground. Now, what you see here is 3 pins. Now, these 3 pins, one is a 5 volt, one is ground, and one is signal. And signal is what you give from either your Arduino or either your controller to control the speed of the motor. And this decides what speed the motor has to rotate at. Now, this ESC is a combination of a lot of MOSFETs inside, which drives at very high current. So a specification of ESC would usually be where it says 30 amp. So that's what you would see usually. It's either 20 amp, 15 amp, 30 amp, 60 amps. There are ESCs at different current rating. So every motor, you'll need 1 ESC. That's very important. Now, another specification that you'll also see is what kind of battery and what kind of how much voltage that you can give. So this particular ESC says it's a 4S, 2S to 4S, which is it can take anywhere between 7.4 volts to 14.6 volts. And also another important thing is the protocol that the signal wire takes. Usually the protocol is similar to that of a servo motor, but some ESCs vary. Like some have PPM, some have PWM. So this ESC that you see is a PWM controlled ESC. Now this is the ESC. Now another important thing with connecting these motors together is there are cases where you'll have to change the direction of the motor. Now how do you change the direction of the motor is when you connect these plugs together. If the motor is rotating clockwise when you give signal, if you have to make it go anti-clockwise, you will not be able to change anywhere in the control, but you will have to change the wires by default. So what you do is you just take out 2 of the wires and interchange. And when you interchange, you will see that the motor rotates in the opposite direction. Now, there are various reasons why there is no switch on this which changes the direction, or you could control it from the computer. We do not want in any case this motor be rotating in any other direction when in flight. That's the reason why we do not have any control to change direction. It will only happen through switching these wires manually. So this is with ESC and the motor. Another important thing is what is called as a BEC. BEC stands for battery eliminator circuit. This circuit is important because inside, when you give a 11.1 volt or a 14.6 volts to this ESC, there's an internal circuit that converts that 11.1 volts to 5 volts, and that powers up all the controllers inside this ESC. Now, if you do not have a circuit called BEC, you will have to externally supply 5 volts through these wires. If you have them, you only have to supply signal, and you don't have to take supply 5 volts and ground to this wire. So that's something that you need to keep in mind. But most ESCs come with 3 wires, so it's easy for you to put it in the controller. So that's with ESC. Another thing is the blade. This blade comes in various size and formats. Every motor data sheet tells you what is the maximum size of the blade that you can use, and whether you can use a 2-blade or a 3-blade system. It's not very simple where you like choose any blade that you want and it works. It doesn't work that way. What you can also note in the specification of a blade is this blade says 1045. Now 1045 stands for 10 inches. 10 stands for 10 inches, and 4.45 stands for how much pitch this blade has. So you take a nut and bolt and rotate. For one rotation, how much tall the nut or the bolt goes, you will determine that is a pitch of the bolt and nut. Similarly, this has a pitch which is 4.5. I'm not sure if it's 4.5 inches or 4.5 centimeters, but it's 4.5. So if you see the curve in the blade is something that actually determines which direction it has to rotate. So if it is rotating anti-clockwise, so this particular blade, if it rotates anti-clockwise, only then it will push the air. So you see it rotating this way. So it means whatever air comes here, it pushes it down. Now, if I have something like this, so if it's going this way, if it's rotating this way, whatever air comes, it deflects it up. Now, if your motor is rotating in clockwise direction, it's important for you to ensure that when your blade is also rotating clockwise, it is deflecting the air downwards, which means your thrust is always downwards. If you're rotating anti-clockwise, you get a different blade called the CCW blade. So blades come like CW clockwise blade, CCW, which is an anti-clockwise, counterclockwise blade. Now this is the clockwise blade. I'm searching for an anti-clockwise blade. It's also clockwise. Yeah, what I have is an anti-clockwise blade. It's not very easy to determine in this particular video, but this is what is an anti-clockwise blade. So we don't flip this blade because it's not going to make its function, because it has a particular curve and function so that it ensures that your quadcopter or your drone is stabilized. Now, another important thing with a blade is its structure and what we call as its balance. Now, most blades may not be balanced. Now, when I balance it here, it may not balance because of crashes or because of non-uniform distribution. You'll have the blades not balancing. This will affect the efficiency of your motors and also cause a lot of vibration. So a lot of professionals balance their blades by keeping it on a pivot like this. Now, this is not how you do it, but they usually do this. And then if you see, this is tilted a little to the right. And they start adding a little bits of tape or some weight, which could be in, say, micrograms or milligrams, not even milligrams, micrograms, so that it balances itself. And this is not something that you need to keep in mind when you're just starting off as a hobby. But yeah, if you're going professional, you will definitely have to consider that. That's called the balancing the blade. And most blades just break when they fall. You also get carbon fiber blades which don't break. And blades prices starts anywhere between 150 rupees for a pair to all the way up to 2,500 rupees a pair. Now, a motors also starts from about 800 rupees for a motor, about 400, 500 rupees for a ESC. Goes all the way up to 10, 15,000 per motor and about 3,000, 4,000 per ESC. Depends on reliability, depends on various other factors. Yeah, what I forgot mentioning about the blade in terms of math. This session is not about for mathematical calculation. This session is only to help you understand basic components of a drone. Another important thing is when you rotate this blade, it displaces some amount of air. Consider this entire thing to be one circular ring, and when it rotates, it goes up, which means that much volume of air is what it's displacing, and that what gives the thrust. Now, the more the angle, the greater the air it can disperse. At the same time, the more blades you have, the larger the amount of air it can disperse. Now, at the same time, you need to keep in mind that smaller blade dia gives you higher speed but lesser thrust. Larger ones give you greater thrust but lesser speed. These things go on like it's a combination, and not, I mean, definitely you cannot use this motor with this blade because the datasheet doesn't specify that you can use this. These are for very high RPM motors and very compact drones. What else do we have? So I have a very small motor here. This motor is about 2800 kV. 2800 kV, and it says M1826. 1826 is its size, and the blades that I can use for that motor is this. One of my favorite batteries, very reliable, is orange battery. A battery that we use will always be a LiPo battery because of the amount of current that this can give. Like I said, each motor requires about 20 to 30 amps of current, which means if you're using 4 motors, you need all the way up to 100, 120 amps of current. That's peak. But on an average, it draws about 60 amps every time the motor is running. So these batteries are capable of giving you about 60 amps of current at the same time. Now, how do you calculate it? Battery specifications comes in 2 forms. One is what is called as 3000 mAh, which is the capacity of the battery. And the second thing is the discharge capacity, which is called 30C, 20C, 15C, which is actually, which says how much current it can give. So when you multiply 3 with 30, you get 90, which means this can give about 90 amps of current continuously without destroying the battery. Now, this is not the case with your regular lead acid battery or your regular lithium ion batteries. They cannot give this much current. That's the reason why lithium polymer batteries are preferred in drones, because it can give about 90 amps of current at a stretch. Now, 3000 mAh means 3 amp hour, which means if you're drawing 3 amps, this battery will last for 1 hour. If you're drawing 30 amps, this battery will last for 6 minutes. If you're drawing 90 amps, this battery will last for 6 minutes by 10. 0.6 minutes. Okay, 0.6 minutes. All right. Yeah, so if you use bigger batteries, you'll see that your drone will last long. But yeah, like I said, not always it will draw about 30 amps. 30 amps is the high current thing. Maximum. It will usually draw about 15 amps. This also depends on the speed at which you're rotating. Another important thing is the connectors that come. These are called XT60 connectors. The speciality about these connectors is the positive and negative is something that you connect at the same time. So when you connect batteries, either lead acid batteries to your car or things, you have seen that there's a momentary spark that comes. We don't want that to happen, and that's the reason why these connectors are used. So I'm just trying to show you how it's connected in the drone. It goes like this, and it connects at the same time. And even if there's a spark or something, that's eliminated by these. So it basically protects. And at the same time, these connectors can also conduct about 60, 90 amps of current. So that's the reason why you have this. Great. XT60 means actually 60 amps of current. And this is where you charge your battery. You get special chargers for lithium polymer. So this is how you charge. This is where you discharge. What do we have next? This is the frame. Yeah. So what I have now is a frame. So this is a hexacopter frame. 1, 2, 3, 4, 5, 6. Thanks to a student of ours, Mr. Slope, who basically delivered who donated this for teaching, learning. So there's a hexacopter frame. I have, this is a quadcopter frame. I can connect about 4 motors to this. 1, 2, 3, and 4. These are the arms. And this is the motor. And this is basically a cushion. Don't wonder what the smiley ball is doing here. You cannot use these blades for drones. Please don't try using these for drones because they'll shatter, they'll break. Yeah, the next important thing is controllers. So this is a Pixhawk. What does this do? This receives command from your transmitter. This receiver, and then it gives input to your individual ESC and then controls all the 4 motors. Now this is a Pixhawk. One of my favorite is a NACE 32 6 DOF. It costs you about 1,400, 1,500 rupees. Pretty standard, good in terms of its capacity. A very low cost controller. These are called flight controllers. It's an avionics series. Or you also get something called as KK boards, KK 2.0, KK 2.5, a lot of them. This is my NACE 32 controller. Oh, wow, great. And then do I have any other controllers with me? This is a Ardocopter. Again, Arduino based flight controller. I am looking for where my, there's one controller that I've put inside this. Okay. Now what do these controllers come with? And that's something that you need to keep in mind. All controllers have something which is the direction. Okay, this arrow mark specifies the direction, and you should always mount the controller in the direction of the arrow mark. Now, what do these controllers have? Most controllers come as 6 DOF. Now, 6 DOF refers to the pitch, the yaw, and the roll of any flight systems. Now, it also has inbuilt accelerometer, which basically tells how quickly you moved in each of the directions. And you have a gyro, which basically gives you your angle of tilt. This is the pitch, which is front, and the sideways are roll, and this is yaw. What I'm turning left and right is yaw. I go like this. This is pitch, and I can't roll my head. It's very difficult. So the roll happens this way. Now, these controllers give that information to these controllers give that information to be able to determine where your drone is at what instant it's moving and how things are going. Now, some also come with a barometer on it, which gives you altitude lock for drones. They also come with a magnetometer, which gives you the orientation in with respect to the Earth's magnetic field. So some go 9 DOF, some go 10 DOF. That's what the DOF means in a flight controller. Another thing is the flight controller gives input to the 4 ESC and takes input from your receiver, your transmitter's receiver. So I'm now going to show you how a transmitter's receiver looks like. Is it? this is a receiver. So it says Fly Sky receiver. It's one of the lowest cost flight transmitter receiver that you will get. You'll get it for about 3,000 rupees. This is the antenna. What you see is antenna. This receives information from your transmitter, and this information goes to your flight controller. The flight controller decides what it has to do to each of these motors, whether to make all the motors go at speed 100 or speed 50. It decides. Now, I will not go into flight dynamics in this particular video, but I'll give you a brief of how it works. Now, this is what your drone is like. And suppose you want a drone to go up, all the 4 motors rotate at equal RPM, so your drone goes up like this. All the 4 motors lessen its speed, it goes down like this. Now, if this motor increases its speed, it becomes this way, which means it's going to go like this. If this motor increase its speed, it's going to go like this in the front. These 2 motors increase its speed, it's going to go like this. If alternate motors increase its speed and the alternate motors decrease, then it's going to do this. Now, controlling this is difficult by controlling each motor with your remote. So this flight controller takes care of that, where it receives the input from the transmitter, and then it decides what has to do, what has to be the speed of each of these motors. Another important thing that the flight controller does is to stabilize the drone always at this angle, where it has to be parallel to the ground. So even in case there's RPM which goes down like this because of wind speed or whatever conditions, your flight controller ensures that it comes back to this condition. So this is your ideal equilibrium position, and your flight controller ensures that it does. And for that, it uses multiple sensors, including gyroscope, accelerometer, your magnetometer, your barometric pressure sensor, and all of these things. Now that's with flight controller. I've covered most part of your drone. I've also told you what prices these come at. This come at about 1,300, 1,500 rupees. Ardocopter, Pixoc, I think starts at about 12,000. Ardocopter, I'm not very sure, about 7,000, 8,000. Been a long time that I've bought these. I don't know what's the standard right now in the market. You can also have GPS and all of other things, which this controllers cannot. But yeah, your Pixoc, your Ardocopters can take GPS, where you can actually lock position and say, I need to get back to a particular point. It'll do it. Now, another important thing, other than all of these things, is your software that basically calibrates your flight controller. So each controllers come with their own software where you calibrate and test each of your systems and then do it. Before I end the frames are these are all plastic frames, but they're reinforced with structures in such a way that they don't break at crashes. Very rarely they break, but if they fall from a very great height, they crash. And this also ensures that you have a very lightweight frame to be able to take the payload. This here is what is called a power distribution board. So you can have only one battery which needs to distribute power to 1, 2, 3, 4 ESCs. So this is the power distribution board through which ESCs are connected. The board can take a lot of high current. That's the reason why these boards are very thick, and they themselves act as a platform for holding your battery. Always ensure that your battery is mounted in the center. So as a CG, or the center of gravity or center of mass of your drone, is always in the center. If that is not taken care of, then your drone starts drifting in one direction, and you have to change things. The last thing that I'm going to show you is the transmitters. Different kinds of transmitters come. This is something that, again, a student of ours donated it after his working. So it's an Fly Sky remote. This is one of the oldest remotes I've had, like probably about 6 years old, 5 or 6 years old. Your remotes are very important. They start all the way from 3,000 rupees and goes up to 1.5 lakh. The more expensive your system is, the more expensive your remote has to be, because reliability is an issue. You don't want to lose your drone midway. So this is about drones. This is about how you work with drones. If you have any questions, you can ask, and we will end the live stream in about 10 seconds, if not. Okay. Thank you so much.